Alright guys, for those of you who still could use some more practice and help a little bit, I'm going to try to do a little bit like another rational that's a little bit more complicated. This should be enough to basically cover all our bases. So let's try something like 5x squared minus 24x plus 27 over, let's say, x minus 3. And let's say, when is that less than or equal to negative 9? Actually, I'm going to do greater than or equal to negative 9 plus 1. Oh, 9x plus 1 over x plus 1. I want greater or equal because there's an extra little thing that'll come up on this one. Alright, so, well, let's go through our steps here. I know that step 1 is going to be 5x squared minus 24x plus 27 over x minus 3 minus negative 9x plus 1 over x plus 1 greater or equal to 0. There we go. We're going to want to get a common denominator. Let's go ahead and do that. X plus 1, 5x squared minus 24x plus 27 over x minus 3, x plus 1 minus negative 9x plus 1, x minus 3, x minus 3, x minus 1, and that, oops, probably could use a little bit more space here. And that should be greater or equal to 0. Greater or equal to 0. Sorry about that, guys. Didn't leave enough room. Alright, and next, let's expand this. So what are we going to get? Let's see. 5x cubed minus 19x squared plus 3x plus 27. You guys might want to take a couple more steps to do that. That's 3x plus 1 minus, it's going to be negative 9x squared plus 28x minus 3. That's the same thing, greater or equal to 0. Alright, let's reduce that a little bit. That's going to be 5x cubed minus 10x squared minus 25x plus 30 all over x minus 3, x plus 1. So this is just the algebra part about it. This is sort of the boring part that we have to do. Alright, another, you know what? This looks like it's going to be a cubic over a quadratic, so I would like to have this, I'm going to expand the bottom, x squared minus 3x plus a little minus 2x minus 3 greater or equal to 0. The reason I want to do this is because I just noticed that we're going to have ourselves a cubic over a quadratic. We're going to have an oblique asymptote. So we need to find out where that oblique asymptote is, right? So let's do that. So oblique asymptote. Let's find where that is. Okay, so let's say 5x cubed minus 10x squared minus 25x plus 30. We're going to divide that by x squared minus 2x minus 3. So 5x cubed divided by x squared is just going to be 5x. That's kind of getting in the way here. 5x cubed minus 10x squared minus 15x is going to give me 0x squared minus 10x plus 30. And that's, so it's just going to be plus 0. That's convenient. So, and that's just going to be, so this is your remainder. So we can say that this is the same as saying 5x that divided by that is just plain 5x plus negative 10x plus 30 over x squared minus 2x minus 3 greater or equal to 0. So I just wrote that in a different form, guys. This is just when you actually do this division. So these two equations, if you were to graph these in Desmos, would give you the exact same graph. Okay, this one is going to be a little bit nicer for factoring, and so we can find our zeros and vertical asymptotes easier. But this is the one that's going to be nice to see the horizontal, or sorry, the oblique asymptote. Okay, so we're going to keep going and get rid of a 5 on the, so I'm going from this guy up here. The 5 factors out. X cubed minus 10x squared minus 25. Oh, that's not how you factor something out. X cubed minus 2x squared minus 5x plus 6 all over, this is x minus 3x plus 1 greater or equal to 0. Let's continue along. This is a 1 obviously goes into this because 1 cubed is 1, minus 2 is negative 1, negative 6 plus 6. So this is going to be 5x minus 1. And so I know the first one's got to be x squared. So x cubed minus 1x minus 1 more x squared. And there's going to be plus x. We need another minus 6. There we go. All over. So anyone who was in my class knows what I just did here. Anyone else, you guys can just go ahead and actually do your long division if you want to figure that one out. And okay, so 5x minus 1 is going to be x minus 6, x plus 1. Does that feel right? Yep. No, that doesn't look right. X minus, no, that does not feel right at all. That feels very, very wrong. X minus 3x plus 2. X plus 2 over x minus 3, x plus 1, greater or equal to 0. And look at that. We have ourselves a rational that we can graph. X. We're going to say let y equal 5x minus 1, x minus 3, x plus 2 over x minus 3, x plus 1. Now we can graph that. I know we have a hole. Let's remember we have a hole at 3 comma something. I might not have to worry about where that comma something is because all we really care about is whether it's positive or negative, above the x-axis or below the x-axis. So I'm not going to worry too much about that. I know I have an asymptote at x is negative 1. I have a 0 at x is positive 1. I have a 0 at x is negative 2. And I have an asymptote. Where's my asymptote exactly? At 5x. 5x. And now I'm just going to, this is just to remind you guys, this part doesn't really matter, because all we care about is whether it's above or below the x-axis. But if I were to plug in a really big number for x, this remainder here is going to be a negative number, so negative 10 times a big number, divided by a positive number, so it's going to be negative, so it's going to be a little bit below the line 5x. And if I plug in a negative huge number, like negative infinity, this is going to be a positive over positive, so it'll be a little bit above. So on the left, it's going to be a little bit above. Now that doesn't really matter for this, so for solving an inequality, because so we're at y equals 5x. So let's see, that goes up to, let's call this 1 comma 5 here. So hit there. Oops, we better make that dotted. And negative 1, negative 5 it should hit. There you go. Now that's not actually, it's not a point. That doesn't matter here. That's just our asymptote. Okay, so let's actually graph this guy. So I know it has to go through right here, and it's going to be underneath our asymptote over here, but that doesn't really matter as long as it follows that asymptote. It's going to cross the y-axis, it's going to come down and reach this asymptote, which means it's got to come from up here, go through this 0, and then hit, eventually, this asymptote. There is our graph. Okay? But what we care about is when is this greater or equal to 0. Right? So I can say therefore this, let's cut that out so I don't have to rewrite it at the bottom. Paste it right here. So I can say therefore this is true when at these intervals. Okay, so when is it greater or equal to 0? So whenever it's above the x-axis or on the x-axis. So that looks like it's here, from negative 2 all the way up to negative 1. That'll be one of the intervals. And negative 2 does count, because it's allowed to be equal. Negative 1 does not count, because it never equals negative 1. That's an asymptote. And then it looks like it flips to the bottom, so that is not a solution. But at 1, it does hit 0, and from then on, it's going to be above the x-axis. So from 1 all the way to infinity is your next set of solutions. 1 all the way to infinity. Oh, I did miss something big time there. What did I forget? I forgot there's a hole. There's a hole at 3. Okay, now it doesn't exactly matter where this is. We know it's positive, so we don't even care where that is. I just know that it can exist at 3. Now if I plugged it in, I would get like 12.5. So this is at 3 comma 12.5. But that's not our solution. The only part of our solution that matters is whether it's above or below. And at 3, it doesn't exist. So my solution should not have included 3. Glad I caught that before ending this video. So the solution goes up to 3, not including 3. And then you got another solution from 3 all the way to infinity. But again, not including 3. And there you have it. There is your solution. That's a pretty complicated one. And that's about as complicated as you'll ever get, especially in the grade 12 course. But yeah, there you go. So that's everything you need to know about solving inequalities and equations with rational numbers. And notice I did not use any really, like all I did was bring everything to the left, make it into a rational, and graph. Alright, hopefully that is enough for you guys for this week. I have a little problem I kind of want you guys to do, so I'll probably do a little video of a problem for you guys to do for enrichment as well. It's kind of a fun one that will require rationals. Okay? I'll talk to you guys soon.